Hello friends, welcome to today's lecture, and today we are going to talk about big data, and this is going to be the very first lecture of this series which I am going to conduct about big data. So this is the very first lecture, and in this lecture we are going to cover the very basics about big data. We'll try to just understand what is big data. We will look at few of the characteristics of big data, and we will also see a small example where we can see big data in action. So let's get started. First of all, let us understand where are we today in terms of the data explosion. So to give you some statistics, as you can see on the screen, today the rate at which the data is growing is just enormous. It's just at a very large scale. To give you some examples in terms of how many Google searches are happening every minute, or how many emails are sent every minute, you can see the numbers. I mean, almost 700,000 Google searches every minute, almost 170 million plus emails sent every minute, close to 100,000 tweets. I'm sure that the tweets are even going to be higher than 100,000 tweets per minute. Close to 700,000 Facebook status updates every minute. So where does all of this data go? All of this data actually goes to the big data processing engines which have been set up by these companies, and they crunch this data, they use this data, they process this data in multiple ways to use further in their analysis process. But the whole point is that data is growing at a very fast pace in the world we are living today. So let's move on to the next slide. So let us understand what is actually big data. So as you can see on the screen, I've also tried to put a small definition of big data so that you can have some sort of a visual memory or representation of this of the definition of big data. So the term big data basically refers to enormous and large amounts of data which is pouring in from various data sources and has various formats. So remember, I have used multiple terms here. I'm saying that the data is coming from various sources and it may have various forms. We will talk about these two aspects in the upcoming slides as well. But the whole idea is that whenever you have a situation where you have lots and lots of data coming in from multiple sources to you, and the data is also coming in different representations, in different formats to you, then probably you are looking at a big data use case. We will also look at some examples of this in the upcoming slides. But for now, let's just establish this understanding that whenever we talk about big data, it is always really large amount of data. And when I'm talking about large amounts of data, it's not gigabytes. It's generally even above terabytes. We are talking about petabytes or exabytes or even zettabytes in some cases. So the data size is really huge. The data is coming from multiple places, and the data is coming in different formats. As you can see in this nice little diagram which I have shown you on the slide, you can see the data is coming from LinkedIn, from Facebook, from Twitter, from Skype, Outlook, WordPress, Pinterest, YouTube, Google Plus, email. So there are so many sources from which the data is coming to a single engine, and now this engine needs to understand this data and process this data. So like I said, we will talk about the concept of varieties and formats in the coming slide, and in this slide we are going to talk about that. So whenever you are given a problem statement where you want to understand whether that problem statement qualifies to be of big data or not, you should always ask yourself whether that problem statement has three characteristics. And those three characteristics are: how much is the volume, how is the velocity, and how is the data looking like. So whenever you have any big data use case, there would always be these three V's present. We call them three V's of big data, which are volume, velocity, and variety. So when I talk about volume, whenever you have a use case where you want to identify that use case as a big data use case, then you should first look at the size of the data. Is the data really huge? is the data looking in terms of terabytes? I mean, I think in today's world, even terabytes is even not that huge. But if the data is looking in petabytes or exabytes or zettabytes or yottabytes, if the data is really huge, then probably that's one of the quality of that use case being identified as big data. The second V is velocity. If the data speed is very high, the speed at which the data is coming to your application is extremely high. For example, like if you relate it to the first slide which I showed you, where we talked about how many emails are sent and how many tweets are made and how many Facebook posts are made. So you can see every minute so much data is generated. So the speed of the data generation is really high. So that is the second characteristic of big data, that it would have a huge velocity of data coming in. The data would be coming at a very high speed to your application. The third V is variety, and variety means that the data which comes to your application will have so many different formats and so many different presentations. It may be email data, it may be data coming from a database, it may be data coming from Twitter feeds, it may be data coming from your computer system's logs, it may be data coming from emails. So the data has so many different forms, it has so many different representations, and that is the third identifying characteristic of big data. So whenever you have a problem statement, and if you are thinking whether that problem can be solved with big data or not, always try to apply these three principles on your problem statement and see, does the data have huge volume, does the data have really high speed, or does the data have variety. Generally you will whenever you have a big data use case to solve, you will generally see all these three qualities in that problem statement, and that is a very strong hint to you to know that this problem space or this problem statement is going to be solved using the big data tools or big data technologies. We are not going to go deeper into what are the big data technologies. So in this lecture, we are just going to restrict our discussion to identifying what is big data and understand what is big data. So hope this gives you a good understanding of the three V's. Remember, volume, velocity, and variety. These are the three V's of big data, and this is what will identify a problem as big data problem. So let's move ahead. Let's go a bit more deeper into the variety part of the big data, which is the third V. And like I said, the data can have different formats. So let's understand generally what different kind of formats we see. Full disclosure, whatever you see on the slide, it's the representation might be something else above than this as well, but generally you will see these three different representations of data. We have tried to categorize the data into three different categories, and these categories are structured, semi-structured, and unstructured. So let's try to understand each of these types of data with some examples. For example, if we talk about structured data, then the data will have a very well-defined structure, a very well-defined representation, which can easily be understood by the application. For example, the data coming from databases is a well-structured data. Because even if it's a SQL database or a new SQL database, let's say the data is coming from an Oracle database or a PostgreSQL database, then it will have rows, it will have columns, it has a very well-defined schema. So that is what we identify as structured data. So any data that resides in a fixed format, fixed field within a record will basically be called as a structured data. Remember, when we talk about structured data, it has a very well-defined schema, which can be understood by the application without much of the processing needed. The second type of the data is semi-structured data, and semi-structured data has some sort of structure, but it's not exactly like a structure which can be just supplied to an application. So for example, if the data source which is coming to your application is an XML data source or a JSON data source. JSON is basically JavaScript object notation language. It's a basically key value pair arrangement. And XML, you have already seen the XML tags, or if you can just think of a web page, for example, where you see a lot of HTML tags, that is also an example of semi-structured data. And so now you can see so that these JSON structures and these XML structures and these emails and these web pages, they have some sort of structure, but that structure cannot be exactly interpreted as is into a programming language or into an application. You need to do more processing. You probably need to take out the body text of an HTML page, take out the title text of the HTML page, take out the meta tags of the HTML page, and then use that information for your application. So you need to do some part of the processing, right? It will not be directly usable, though it will still have some defined structure which will help you understand the overall structure of the data. If you just look at an HTML page, you can identify what is in the title, what is in the body, etc., etc. So it will give you some sense of the structure, but it will still not be as structured as, for example, a database. That is semi-structured. The third type of data is unstructured. And unstructured data is like a data which does not have any structure. For example, a Twitter tweet or a Facebook post. Now it's just plain text. It does not have any structure, right? So you need some mechanisms to convert this data into a representation which can be understood by your application. So that those kind of data types or data formats generally come into the unstructured categories. It can also be audio files, it can also be video files, it can be images, for example, or it can be huge PDFs with research paper documents. All of this data goes into the unstructured data category. So let's move ahead. And like I said, once we establish some basic understanding of what is big data, the 3 V's of big data, what is structured, semi-structured, and unstructured data, we will talk about an example. And this is the example which I have presented here. And this example is quite relevant in today's context, because as we know that we are going through tough times, we are going through a novel coronavirus situation right now, which is spread all across the globe. So at this point of time, a lot of data is being generated. In fact, if you would have looked at some of the news channels or some of the news portals or even the mobile app of those channels, you would have seen that those portals and mobile apps are providing you some sort of infographics or a nice graph representation where it will show how the coronavirus cases are surging up, or when the curve is flattening, when the curve is going down, what is the fall rate, what is the death rate, what is the recovery rate. So all of that data is represented to you, right? So have you given a thought as to how that data is being generated? Because imagine that if you have to prepare such infographic for a geography like India, for example. So India has so many states, right? So and those states have so many hospitals. So all of the data is being logged by doctors somewhere in different formats. Somebody is logging in with a digital form. Somebody is just clicking a photograph of it and sending it as an image. Somebody is writing an email and submitting the email to the main medical server, and then all of that information is being passed on to a big data processing engine, and then that big data processing engine is utilizing that data to show you nice infographics as to how many cases were discovered today, how many people recovered today, how many could not recover, etc., etc. So this is a very classic example of big data processing, that we are using all this patient data and all of this medical records data to basically create infographics and do further analysis of this coronavirus situation. It can also include the data like cell phone tracking or travel history or body temperature and latitude, longitude. Basically, it's a lot of information. And now you can see the 3 V's here: the volume, the velocity, and the variety. The volume of the data will be very huge because a lot of people would be submitting the data. The variety of the data will be very different. Somebody would be sending an email, somebody would be sending an Excel sheet, somebody would be just clicking a photograph of the prescription which they have prepared, or the report they have prepared, and just uploading that report as image or as a PDF, or somebody would just be submitting the information via a digital form from the online portal. So it has so many representations, and we talked about the volume as well and the velocity as well. So the data is coming at a very high speed, that it's a lot of data, and it has different forms. So it basically satisfies the three V's we talked about, and that is why this is a case study which I thought would be interesting, so that we can relate and understand what is big data and where all big data can be potentially be used. So this is the last slide of today's lecture, guys, and I would like to stop today's lecture here. So thank you all for joining in, and we will meet in the next lecture.